right, guys. One thing I will say, especially with the homework, if if you're looking at WinGauge and there is no assignment score on it, there's a good chance it's missing. You haven't turned it in yet. That's a good rule to go by. If you're sure that you did it, all you got to do is email me, and I can let you know that if I do have stuff yet to grade or I need to grade, I'll let you know and I can double check once we get back here, especially if you're looking at it at night or sometimes after school hours. I can check there. If your parents are looking at the assignments, because sometimes they ask why is there a 0 here or whatnot, check and see how many points it's out of. Is always a good thing to check, because there are going to be, especially after the chapter test, I do make up points on the chapter test. I put its own column for that point, so it's NUP, make up points, but it's 0 out of 0. So yes, it is a 0, but it's out of 0 points, so you're not actually losing any points for that because it's not worth anything.
How do we keep it?
So the chapter test will come up after this one, so not next week, probably the week after. So that's normally a 4-day process, because the first day is going to be a makeup day. We kind of had one of those already. Up on the board, I will have pretty much the assignment names as y'all seen in WinGauge. So it'd be 2-1, 2-2, 2-3-1, 2-3-2, 2-4. Yeah. And then the second day is going to be a review day. I will give you a review sheet for y'all to work on. You'll have the whole hour to work on it. I would, again, if you want to use your notes, books, well, it'd be the note sheets. Ask neighbor, ask me questions. That's fine. I think it'd be very helpful to try to go through and do at least 1 or 2 of each without anything. Because if you're able to get through the entire review sheet, answer all of them without any additional help, you're ready for the test. That's the main thing. The third day, especially if some of them on the review sheet you weren't sure about or wanted extra help or kind of additional information on, we go over it. For the most part, I'll normally hit 1 of each type, and I'll just pick one at random. There's no real rhyme or reason for how I pick them, unless y'all want one specifically to look at or want to go over it. On the flip side, if y'all feel great about the review, don't have any questions, we'll blow through it, we're done. Because again, going over it's to help y'all, any questions that you had on it. And the fourth day is the test itself. You can use the review sheet on the test, but you can have something to write with, your review sheet, and a calculator. That's about it. I don't let you all use your notes on the test. It's mainly a review sheet. So if there's any formulas that we've had already with the vertex form or standard form, put them there. What the problem is about vertex form or standard form, just put them right next to the problem so that you have them there. The test and the review are worded very similarly, or almost the same wording for the problem set. I try to keep them very similar. I try to make the review sheet harder than the test, because if you can do the harder problems, you know you're ready for the test. But then that's about it. Now, you can do makeup points. You can come back at a later time. I don't normally give you time in class to do it. Just talk with me, and we can schedule a time for you to come in and just correct the ones you got wrong and earn back half the points. So I don't put the correct answer on the test. You're just coming back and fixing it and earning those points back. And in that NUP column, that's where I put the points that you earned back from that there. All right. One more questions. Yes? Okay. Okay. Which one would you like to look at? 17, 19, or 21? 17. So we're looking at problem 17 from 1-7. So it told us that we want to find A plus B. Now it defined matrix A as 9, -6, 7, 5. It defined matrix B as 4, 3, -7, -6. And we won't need C for this problem, but it did define C as 0.5, 3.6, 2.4, and -3.2. So for 17, we're just adding these two together. So it's saying A, we take matrix A and add it to matrix B. and then we add corresponding elements. And get our result. Well, our 9 plus 4 is 13. Negative 6 plus 3 is negative 3. 7 plus negative 7 is 0. And 5 plus negative 6 is negative 1. Now, the other way we could have done this is typed in to the graphing calculator A, B, and C, and recalled A and B. So second matrix edit is a 2 by 2, 9, negative 6, 7, 5. Second quit, second matrix. We'll edit matrix B, which is also 2 by 2, 4, 3, negative 7, negative 6. Second quit, second matrix. C is a 2 by 2, 0.5, 3.6, 2.4, negative 3.2. And once we have those typed in, I can recall matrix A plus second matrix B, and we get the answer there. The next one was 2 times our matrix B minus matrix C. And the last one, we'll go on and do it, matrix A plus matrix B plus 10 times matrix C. That's it. So you can do it by hand. The graphing calculator will also do it. Yeah, we'll look at 21 and then we will so we're looking at 2.1, 21. G of x is equal to 2x squared. Now, there's one main answer. There's 3 parts or 3 things I'm looking for with this one here, because we're describing the transformation, and the main thing that we have is the 2 inside the parentheses with the x. That means it's a horizontal stretch or shrink. So especially when I'm grading this, first thing I'm looking for, did you be able to tell it's a horizontal, not vertical? The second thing we need to look at, or before we define it as a stretch or shrink, we need to take that value of 2 and flip it. So our value of B, this stretch or shrink, is not 2, it's actually 1/2 because it's horizontal. And because it's 1/2, between 0 and 1, it is a horizontal shrink of 1/2. So really, when I was grading this, I was looking for 3 parts. Did you identify it as horizontal, not vertical? Did you get it, the fact that it was a shrink, not a stretch, and the factor of 1/2? So as long as you got 2 of the 3, I gave you the point. Because if you got horizontal stretch of 1/2, I just fixed it from shrink to stretch, or stretch to shrink, and kind of gave it to you. But if you got 2 out of the 3, you got horizontal but missed the other 2, I took a 1/2. Does that make sense how that works? Because homework, I'm only looking at halves. I might do quarters if here than there, but it's really, did you get the whole question or did you miss at least half or more? Then I'll take half. On a test, I would deviate out the points a little bit more evenly, but homework, a little more gracious on it. Because again, it's your homework, you're trying to learn it. All right. What we're looking at today, there's 2 parts to this that we're doing. First is minimum and maximum. Minimum value, maximum value. Now for the quadratic function ax squared plus bx plus c, there is a minimum and maximum value. Highest and lowest point on a parabola. Now, when we're talking about minimum and maximum value, what the value that we're looking for is the y value. How far up or how far down on the y-axis is this graph? And it's not going to be y equals, it's just this is the minimum value, the y value. And interestingly enough, the minimum value or the maximum value is the y value of the vertex. Because the vertex is the highest or lowest point. It's the lowest point if the graph opens up. It's the highest point if it opens down. And it's just whatever the y value of the vertex is. So that's all that f of negative b over 2a is. It's the y value of the vertex. The negative b over 2a, as we found yesterday, is what we do to find the x value of the vertex. Quadratics, all higher degree polynomial functions, the domain's all real numbers. All that's saying is we can plug any real number in and get a value out. That's all that means. Range is just what y values are covered. Decreasing, increasing. It's just reading the graph from left to right. Is the graph going up or is it going down? If it's going down, it's decreasing. If it's going up, it's increasing. So if we look at this one here on the left, starting from the left, from here to here, as we go from left to right, the function is going down. So it is decreasing. And after the vertex, it goes up. So it's increasing. That's literally all that means. And the point where those two met, that vertex, that minimum value, we call it a turning point. Because it turned from decreasing to increasing, or increasing to decreasing, because the next one increases to that point and then decreases. So that's a turning point. That's all increasing and decreasing are. There is a third one, third option, constant, flat line. It's not increasing, it's not decreasing, so it's constant. Questions on that there? Okay. I need to go back and readjust these slides so that they're not so pixelated. Find the minimum or maximum value of this function. Describe the domain range of the function and where the function is increasing or decreasing. So really all this is saying and what it's wanting is us to find the vertex and go from there. Well, the vertex for this here is our negative b over 2a, comma f, and negative b over 2a. Because if we have the vertex, we can describe this here. Ax squared plus bx plus c. Well, a in our case is 1/2. B is -2, and C is -1. So to find this here, our negative b over 2a would be -2 over 2 times 1/2. Now at this point here, we can plug it into a calculator. Fraction, -2 over 2 times 1/2 is 2. So the x value of the vertex is Now to find the y value of the vertex, our f of negative b over 2a. We plug it back into the function, yes? Now we can type this all into the calculator. Again, we don't have to do any of this by hand. 1/2 times 2 squared minus 2 times 2 minus 1 is 2 negative 3. So this is the key point because it helps us find everything from there because the minimum or maximum value is that y value. It's a minimum value if it opens up. It's a maximum value if it opens down. And we can go left and right. 2 ways we can figure this out. One is based off the value of a. If a is positive, it opens up. If a is negative, it opens down. Here, a is positive, so that means that negative 3 is a minimum value. If it had been a negative 1/2, it would have opened down. It would be a maximum value. The other way is the graphing calculator. We can graph it and see how the function looks. Now, there's 2 ways we can plot or do the 1/2. One of them is turn it into a decimal. The graphing calculators, the 38 or the TI-83s, won't do a fraction. They will, but you have to actually put it as division. The 84s, the ones we have in here, alpha y equals enters will do a fraction. That's the biggest difference between the 83 and 84. And at this point, it's a $50 difference. 40, 50 bucks. 1/2 x squared minus, not x, 2x minus 1. This is the graph we have here. And if we look at the table, at -2, or 2, -3 is the vertex because we do have that mirror across either side, yes? Looking back at the graph, well, we can see that that point is the minimum because it's the smallest point. Everything else is going up from there, yes? Okay. So minimum. Minimum is -3. From that, we can also get the range. Range is our y values, the output, the values that we get out of it. Well, we just said the smallest value, the minimum value was what? -3, right? So all the y values should be what? Bigger than. So y is greater than or equal to. That's the range. Ready for the domain. Any quadratic, the domain's all real numbers. Increasing, decreasing. This here we're talking about a set number on the x intervals on the x-axis. So going from the left, so we start at -infinity. Coming over for the right, well, we can see that the function is going down, yes? So it starts off decreasing. So decreasing, we can say from -infinity, because again, x's. It decreases all the way up to the vertex, yes? So what's the x value of the vertex? 2. And we put parentheses. So negative infinity to 2, the function is decreasing. It's going down. And then at 2, it does what? It starts increasing all the way, all the way to infinity. That's it. Decreasing, increasing. There are some higher degree polynomial functions that it'll switch between increasing, decreasing, back and forth, because it's not uncommon. Yeah. You have a function to do this here, and this really just takes off. So it's increasing, decreasing, increasing. It can fluctuate between one and the other. Or we can have a straight line that's just either always increasing or always decreasing. We can have different versions of this here. You kind of understand what this is? All right, we're going to move on. The last type of quadratic that we can have is called x-intercept form. And we call it x-intercept form for one main reason. These two equations here give us the x-intercept where it's going to cross the x-axis. So our vertex is going to be the point P plus Q over 2, comma F of P plus Q over 2. Axis of symmetry is halfway between these 2 points, P and Q. Which means the axis of symmetry is x is equal to P plus Q over 2. And we have one less thing, the x-intercepts. And that's going to be P comma 0 and Q comma 0. Questions on what we've had so far? And still, if A is positive, that number in front of the parentheses is positive, it opens up. If it's negative, it opens down. With all this here, this one, x-intercept form, is really revolving around the values P and Q. So if we compare our negative 2 times x plus 3 times x minus 1 to the general form, we can find the values of P and Q. Looking at this here, what's the value of Q? I would halfway agree. 1, because we have x minus q, x minus 1. X's line up, our signs line up, so q is just 1. Now if we look at p, x minus p is now lining up with x plus 3. So yes, it would be negative 3. So p is 3, but the only way to change it from our minus in the general form to plus is if p's value is negative. So you see how that works. So we feel good about finding P and Q. Is there anything restricting me on saying that P is 1 and Q is negative 3? All Not really. I mean, we can multiply two things in any order, yes? They can be interchangeable all we want, but we do need to make sure that we don't repeat one of them. P can't be -3 and -3. We have to attach P to one, Q to the other. You just decide which one you want. Now, if you want to keep it this way here, P is the first one, Q is the second, go for it. Because there's nothing saying, because really what I'm saying is this. I didn't change formula, I just flipped how it was written. It still works. Okay. We feel good about finding P and Q. All right, let's start finding our information. Let's go with vertex. Vertex is P plus Q over 2, comma, F of P plus Q over 2. Well, okay. P plus Q over 2. Well, P's value is -3. Q's value is 1. So we're saying -3 plus 1 over 2. Well, -3 plus 1 is -2. And -2 over 2 is -1. Questions on how we found P plus Q over 2? We feel good with that there. Now the F of P plus Q over 2 is exactly what we did yesterday. I'm going to take that value and plug it back into the function. So for us, that would be -2 parentheses -1 plus 3 times -1 minus 1. We're just plugging it back in. Yes, we could have thrown the previous one in too. There's -2 parentheses -1 plus 3 times -1 minus 1, and it gives us 8. Vertex is the point -1, 8. Well, it's also nice. Axis of symmetry. On the general form, it's what? X is equal to P plus Q over 2, yes? Well, that is the value we already found, which is -1. So we have the axis of symmetry. We already found it as a part of the previous problem. The only thing we're missing is the x-intercepts, yes? And I know most of y'all are about to run out of room. Well, our x-intercepts. Let's see here. Make sure I didn't flip those. No, I did. Yeah. Well, I just flipped the signs, not so much the numbers. Because for the vertex, I think what you were asking, or x-intercepts. Yeah, so the x-intercepts, P comma 0, 1 comma 0. And 2 comma 0, -3 comma 0. Yeah. Oh, yeah. So if you want to keep P and Q kind of lined up, -3, 1, yeah. Because even listening to these here, they're just 2 points. Order doesn't matter. Negative 3, 0, 1, 0. Questions on this here? We would, I think, agree that there is more information listed here for this problem than in the previous two. But I don't think this is any more calculations than we did on the last one. We just did P plus Q over 2, plugged it back in, got most of it. And the rest of it was revolving around P and Q. Because if we graph this, negative 1, negative 8 would be this point down here. We'd have our axis of symmetry, negative 3, 0, 1, 0. I mean, we have a decent idea of what the graph looks like. Questions on this here? I definitely need to redo this note sheets so that y'all aren't having to fight that graph on half the part. Yep, definitely gonna do that today. Questions on this here? So let's look at this here. Oh, yeah. So, general form, A times X minus P times X minus Q. Let's find P and Q. 4, yes. Almost. It is 4 and negative 2. Because if we look at the form X minus P, X minus Q, X minus 4, so the P value is indeed 4. X plus 2, well, it changed from minus to plus, so the value of Q, that 2 has to be negative. Because we're almost switching the sign as we're pulling it out of those parentheses. So
So what you're saying is if the top, say the number 2, if that's a negative,
yeah,
or the top of the positive 2 is going to be negative B. You have to switch the signs.
yeah. Because really for us to have the X plus 2, it's X minus negative 2. For it to really match up with the X minus Q's value. Or really when you're pulling it out for this here, we're flipping that sign. Because X minus 4, it's not going to come out as negative 4, it comes out as positive 4. X plus 2, it's not going to come out as positive 2, it comes out as negative 2. And that's really just because of our X minus in the general form. Well, as we're doing this here, might as well do our main, go on to do our main calculation before we start listing anything, because the main two calculations we have is our P plus Q over 2 and then plugging it back in. So for this here, we'd have 4 plus negative 2 over 2. We didn't do this on the first one, but we can do this in the calculator. 4 plus, not negative 52, negative 2 all over 2. 30xs, 4 plus, I can calculate the top and divide it by the bottom. So this is 1. When we plug it back in, we have negative 1/3 times 1 minus 4 times 1 plus 2. Negative 1/3 times, lost the equation, 1 minus 4, 1 plus 2. It's 4 times is 3. We ready to identify our parts here? Vertex 1, 3, our P plus Q over 2, comma F of P plus Q over 2. what we just found. Axis of symmetry. X is equal to 1, or P plus Q over 2. And lastly, X intercepts. The y value of the x-intercept will always be 0. Now we just need our p and q values. So we would have
So it'd be
4
negative 2.
and -2. That's all I'm wanting for the homework. Is that there? I'm just rewriting out the, and then I might have flipped those, but we just need P, comma 0 and Q, comma 0 listed. Questions on this here? Do we need to see another example of one of these? That's it. That's it with 2, 2.